All right, this is Note-Taking Guide 5.6. Today we're going to talk about dependent or independent probabilities. So here the definition, it says two events are independent if the occurrence of one event does not affect the likelihood that the other event will occur. Two events are dependent events if the occurrence of one event does not affect the likelihood that the other event will occur. So just a second ago in class, I talked about how if I offered Kobe a donut out of a box of donuts, his probability would be one thing. And then if I offered Toa a donut out of the same box, his probability would be different because Kobe already took a donut out of the box. That is a dependent probability. Toa's probability depended on what Kobe's probability was. So that's the difference between dependent and independent probabilities. So we're going to look at some events today, and we're just going to decide whether or not they're independent or dependent. So independent means they stand by themselves, they're not affected by other things, and dependent means their probability is affected by another probability. So here's our first example. You flip heads on the coin and tails on another coin. Does one probability on the coin affect the other probability on the other coin? It doesn't, right? So are these dependent or independent? They're independent. One doesn't affect the other, so it's going to be independent. Okay, questions on that? Okay, the second example, your teacher chooses class president, then she chooses class vice president.
Dependent.
Yeah, why is it dependent? Yeah, you're right. That's exactly right, Devin. That's awesome. You have one less person to choose from. Because once you choose president, you don't have that person to choose for vice president. So there's one less person to choose from, which affects the probability. Are you seeing how those probabilities will work today? Okay. So another two examples to just decide whether or not they're independent or dependent. This one says you choose... I know. You're right. You choose a blue marble from a bag. That's what happens when I make my own worksheets. And set it aside. Then you choose a green marble from the bag. So what about that? What do you think? Independent or dependent? It's dependent. Why is it dependent?
Because you already, I don't know how to explain it, because you already chose the second one.
Yeah, and we didn't replace it, right? We chose one, we didn't replace it, which means there was less to choose from the next time. So that affected the probability of the next one. Nice job, you guys. Okay, the second one here on this example says you roll a 5 on a number cube and spin blue on a spinner. Those are independent. They have nothing to do with each other, do they? Okay, questions on how to decide whether or not something's independent or dependent. Okay, so the probability formula for independent events, it says here, the probability of two independent events, A and B, is the probability of A times the probability of B. So we're just gonna find the two probabilities separately, and we're gonna multiply them together. Okay. Did you notice that the word is and when that happens? That's just for future reference. But okay, so here's my probability question. You flip 2 quarters. What is the probability that you will flip 2 heads? Well, what's the probability of flipping a head on the first quarter?
50%.
Yeah, 1 out of 2, right? Or 50%. What's the probability of flipping a heads on the second quarter? Same thing, because it didn't affect each other, right? So what's the probability of flipping a heads on both quarters? 1/4. Now you guys, I'm okay if you write that as 0.25. I don't care which way you do that. It's up to you. On some of the problems that you do today, when you punch in your fractions into the calculator to multiply them, it will automatically go to a decimal point number for you. So if that's the way you do it and it happens, I'm fine with that. Leave it as a decimal point number. I always try to write mine as a fraction if possible. It just makes more sense when you read that it's 1 out of 4 that would happen as your probability. Or 0.25, which would change to 25% of the time, right? So probabilities can be written as percents also. Okay, the next one says, you flip a coin and roll a number cube. What is the probability that you will get heads and 6? So what's the probability of getting heads on the coin? 1 out of 2. And what's the probability that you're going to get the number 6 on a number cube? 1 out of 6. So what's the probability of both of those happening? 1 out of 12. Because you just multiply those together. Again, it's okay if you change that to a decimal point number. So what do you think so far? That's not bad, right? We're fine. Okay, this is the formula for the probability of dependent events. So what it says here is the probability of 2 dependent events, A and B, is the probability of A times the probability of B after A occurs, which is what this says right here. So it kind of is a confusing formula when you think about it that way, but when we talk about the math, it's pretty simple. Because again, back to that example of the donuts, if I had a dozen donuts, then Kobe gets to choose from 12 donuts, but how many donuts does Toa get to choose from? 11. So do you see how the numbers are changing? That's, yeah, if we're counting how many times I see your name on the video, then a couple of you are ahead. You guys, so this probability of B after A, that's what it's saying, is that we went from 12 donuts available to only 11 donuts available. So the probability after something occurs. Okay, so here's an example that shows that. It says you randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? Well, first of all, we need to know how many flowers are total, right? So how many flowers are total?
28.
Wow, good job, you guys. Okay, 28 total flowers. So what's the probability that you choose a purple flower? 7 out of 28. Now, there's not going to be 28 flowers left if you take it home with you, is there? So when your friend picks their flower, their yellow flower, they have 9 out of a 27 chance of getting their yellow flower. Does that make sense? Or, yeah, yellow flower. Does that make sense how that probability had to change? So this is what happens when those probabilities are dependent on each other, okay? Then you can just punch that in your calculator. This is one of those kinds that is going to change right to a decimal point number for you. Shout it out at me when you get it.
112?
Yeah, I get 112.
0.083?
Oh, 1/12, is that what you said?
Yeah.
All right, maybe I did something wrong earlier when I did it on my paper.
Yeah, that's what it is.
Okay. All right. It will eventually, on some of them, change them straight to a decimal point number, and that's okay too. Did anybody change 1/12 to a decimal point number?
It was like 0.083.
Okay. And that's okay if you leave it that way too. All right, I think there's a couple of problems on the back of this, so let's go do 2 more. There are 8 shirts in your closet, 4 blue and 4 green. I need to take the R off that, don't I? You randomly select one to wear on Monday and then a different one on Tuesday. You wear a blue shirt on both days. Find the probability of this occurring. So what's the probability of having a blue shirt the first day? Okay, four blue out of how many total shirts?
8.
8 shirts in your closet, right? 4 are blue and 4 are green. So there's a total of 8 shirts. So this would be blue out of the total. Does everybody agree with me? 4 out of 8? Okay. That's the first day. What happens on the second day if you already wore a blue shirt? How many blue shirts are there to choose from? 3 out of how many? Nope. 7. How come 7? You already wore one. You don't have 8 left to choose from, right? I know some of us wear stuff out of the hamper probably, and that is going to ruin your probabilities, you guys. After we wore it, we don't have a chance to wear it again. So what do you get when you do the probability of that happening? I also got 3 out of 14. Thank you. Okay, questions on how we did that? So don't forget, you guys, that not only sometimes you have to subtract one from the top number, but you might also have to subtract from the bottom. It's okay to have to arrange those numbers. Remember to find that second probability based on that first one already occurring if it is dependent. Okay, one last one. You roll a dice twice. The first roll you get is a 5. The second roll you get is a 6. Find the probability of this occurring. So what's the probability of getting a 5 the first time? 1 out of 6. What's the probability of getting a 6 the second time? Yeah, they didn't even actually affect each other, did they? So what's the probability of that happening? 1 over 36. Okay. Questions on independent or dependent?